Okay, let's take a look at this problem here. The chemical equation that describes what happens in an automobile storage battery as it generates electrical energy is PbO2. What's PbO2 called? Lead 4 oxide plus Pb, lead, plus H2SO4, sulfuric acid. And so this is what happens in a car battery. Car batteries, batteries in general, these are redox reactions. Car batteries generate electricity. We need some transfer of electrons. Can you tell what the oxidizer is and what the reducer is? And what it forms is PbSO4. PbSO4 is called lead 2 sulfate plus water. And so what's happening to lead 4? Well, what's happening to lead 4 is lead 4 is going to lead 2. What's happening to lead metal? Lead metal is going from 0 to plus 2. To go from 0 to plus 2, it loses electrons or gains electrons? Loses 2. And to go from plus 4 to plus 2, it must gain. And so the oxidizer here is lead 4 oxide. The reducer is lead metal. That's what's happening. And so the first question is, what fraction of lead in lead 2 sulfate comes from PbO2? And what fraction comes from elemental lead? And so there are two leads here. One of the leads comes from PbO2, the other lead comes from Pb. And so as far as a fraction, half the lead comes from this, the other half comes from that. In other words, 50% from this, 50% from that. This is a balanced chemical equation. And so it's a 1-to-1 ratio. If the process uses 29.7 grams of PbSO4, what mass in grams of PbO2 must have been consumed? And so uses, actually it doesn't use, it produces. PbSO4 is a product. So if the process produces 29.7 grams of PbSO4, what mass in grams of PbO2 must have been consumed? And so all we do is, we don't have to pay any attention to part A. Part A is irrelevant for this. All we're doing is grams of A, for this, we're going from grams of A to what? So we'll go from grams of PbSO4 to, well, this is straight stoichiometry, so go from grams to moles. So we're going to go from grams of PbSO4 to moles of PbSO4, moles of PbSO4 to moles of PbO2, moles of PbO2 to grams. We don't have to worry about this 50-50 stuff because we see it in the mole ratio. For every 2 moles of PbSO4 that are produced, how many moles of PbO2 was reacted? 1. It's a 1/2 ratio right there in the mole ratio. So we don't have to worry about part A. It's not going to impact anything. This is straight stoichiometry there. And we can call that B since it's a product. So grams of B to moles of B, moles of B to moles of A to grams of A being the reactant. But it doesn't really matter what we label A and B. So this is just a straight stoichiometry problem like the earlier ones. 81, hydrogen and chlorine are produced simultaneously in the commercial quantities by the electrolysis of salt water. So electrolysis is you take salt water like this and then you pass electric current through it. Pass electric current through it, then the salt water is converted into sodium hydroxide, hydrogen gas, and chlorine gas. Yield from the process is 61.0% by mass. What mass of solution that is 9.6% by mass sodium chloride must be processed to obtain 105 kilograms of chlorine? I think this is the problem I stopped at, but I don't remember. And so this has 2 percentages. Yield from this process is 61% by mass. Another percentage, 9.6% by mass sodium chloride, that is a solution. And well, 1 is 105 kilograms of chlorine, which is a product. And so here, it's 61% yield of product. Which means 61 by mass. This is a mass percent. And so 61 grams out of 100 grams. 61 grams of what out of 100 grams of what? Well, what are they interested? Which product are they interested in? Sodium hydroxide, hydrogen, chlorine. They're interested in chlorine. And so chlorine is what they're interested in. So it's going to be here. 61 grams of what? Chlorine. So 61 grams of chlorine per 100 grams of what?